tutorial online 一堂课吧，我不要玩。晚上在家上。
Every class you record then you must consume a lot of memory.
还好。
Then you can sell the video course.
I don't sell. 不要被抓家了。Brandon want to sell.
Brandon 4.0. Okay, I think today we are going to cover quite a lot of things. So you try your best to digest, right? So otherwise, you probably have to put some effort to study yourself at home. If you don't understand, you can come back to me any time now. So while you're download, I think we should start first. Otherwise, we lack of time. Okay. So what is NLP? Natural language processing. What do we need to process natural language?
Communicate with computer.
Communicate with computer. Okay, one of the reasons, right? So this is natural language. So this is processing. So in short, we are going to process the natural language, for example, English. So the reason why we process the natural language is to convert the text into more meaningful format, so that the machine can actually try to understand what humans want. Okay, but as I mentioned during the first lessons, machine doesn't understand the meaning. Okay, so this one is behind the mind. Machine doesn't understand the meaning, but they will try to understand in a different type of format. Okay, for example, I'll give you one situation here. We have a two sentences here. I ate London. Right now.
Brandon.
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 Okay, I give Brandon a pen. So we have a second sentence here. Brandon was given a pen by me. So we have two different sentences here. Do you think these two are same meaning? Same. But for machines, how do they know that these two sentences are the same? Have you ever think that how machines understand these two sentences are the same? So that's the reason why we have to perform a series of process, okay, in the simplest way, so that the machine can understand. Okay, so I'm going to show you the overall process first, and then we will go through each of this process. How are we going to put it into Python? So first step, what we can do here is to tokenization. The purpose of doing the tokenization is we are going to break the whole sentence into individual bits, or we call it as a building block of a sentence. We put it as an individual bits here. Okay, so that is the first step, tokenization. So after that, what we can do? We can actually remove the stop words. So what is stop word here? Stop word is referred to the word that is not significant. That is bring a minimal meaning to one sentence. You remember, if the more value, the more the word you have, the more memory, the more the time that the machines need to process. So we try to reduce the size of the string by removing the words that is not very significant. So the word that is not very significant, for example, maybe it's not significant. Maybe was is not very significant. How do we know that the list of a stop word? We have the library in the library of the so-called NLTK. So you don't need to worry about what is the list of a stop word. We have the list itself. Whenever you have this word appears, that it will automatically remove for you. That already identify which words are not very significant. So 10 is not important. Maybe 5 is not really important. So you can see that the size is getting smaller and smaller, right? So after that, what we do here is we can actually perform a process, the so-called lemmatization. So lemmatization is a process to convert the inflected word back to the original word or back to the base word. What is inflected word? Okay, inflected word is words that already modified. For example, run. We have a running. Okay, run. You can back to the brain. Okay, and then we have a give. Okay, give can go to given. Past tense, give can give to gave. And so all these are actually called inflected words. So we are going to convert this inflected word back to the original word. Okay, so after we back to the original word, so this give here is back to give. Given also back to give. Okay. So the more process we can do, another process we can do is maybe to lowercase the words here. So although we have a Brandon in the first sentence, it's a start with a capital B. The second one is a small b. But the machine will treat them different things, different features, different words. So we are going to convert this to lowercase Brandon. This one I. Oh, forgot. So this me. If you go back to the lemmatization, this one is actually go back to I. Okay. So done. So after that, what we'll do here is we will count the frequency of the word, each of these letters inside a second. For example, we have a letter I, give, Brandon, 10. So we have a sentence 1, we have a sentence 2. So this is individual word here now. So this individual word here, we call it as a features in NLP. Okay, so in the first sentence, I, we have 1, give, we have 1, Brandon, we have 1, 10, we have 1. Brandon, the second sentence, we have 1, give, we have 1, 10, we have 1, and I, we have 1. So if you compare, they are 100% exactly the same. So this is how machines try to understand the sentence based on the frequency, based on the occurrence of the features that occurs inside one sentence. Okay? So it's not through the grammar like us, we study, we understand the meaning, but for machine, it's impossible. So we try to compare, we try to give some value for the machine try to learn. Is that clear at this stage? So this is how the machine is trying to learn a string. It's not through the understanding vocab or pronunciation, no. It's based on the occurrence, the count. Okay? So in order to process all this stop word, tokenization, lemmatization, you need a library. So most of the one of the most popular libraries that are available here is called NLTK. Okay, so if for time, then I will cover a little bit of the text block, and then some other libraries, for example, Monkey-Dance, you have a Google Cloud and users here. I'm not going to cover everything, but I will just cover the most popular library. It's called NLTK. NL is called Natural Language Toolkit. So in order to use this NLTK, you need to download the whole package into your drivers. So there are several ways to install this package. The first one, you can copy this called PIP install NLTK. Okay, so I put an exclamation mark here. So this is to download the whole package and to import the NLTK into the notebook. So you can try to run this code. So this is our first way. So after you install, then you will prompt up one document at the bottom here. You try to click and launch this document. So you can download the whole package. It's up to you, but it's going to take a lot of time because you download everything here. So this is one way. This is one way. If you don't like this way, it's okay. What you can do here is you can go to the search, type the form, Anaconda form. Okay, go to the Anaconda form and type PIP install NLTK. So this is second method. Okay, first way, inside the notebook, you type. So this is first way, yeah, in the notebook. You can type exclamation mark PIP install NLTK. So this is one way. The second method is you can go to the Anaconda form and type PIP install NLTK. Okay, so if you type PIP install NLTK, you type enter, then you start to select the libraries here and put it there. So the second way will be faster compared to the first method. Then you will see the requirement already satisfied, means that done. You already downloaded the NLTK successfully. So this is second way. Are you able to follow me? Yes, sir. So there are another method where you can download this package. Okay, you can go to the Anaconda Navigator. Okay, you can go to the Anaconda Navigator. Alright, so under this Windows here, you go to the left, okay, you check this environment. Okay, you go to this environment here, go to the top right corner, search the package, you type NLTK. Okay, you search NLTK. So I already downloaded through the prompt, that's why you will see that NLTK is already downloaded, it's already so tick under the install folder. If you haven't downloaded, then by right you will store inside the uninstall folder. Then you install from here also can. So there are three different techniques how you can install the package through the notebook, through the form, or through the Anaconda Navigator environment. Okay? Okay. So let's continue. Anyone cannot download the package? Let me know. Oh, okay. Good. You.
Thank you.
You. Anyone? I do one now, huh? You haven't started, huh? Lost already. Lost already. Okay, so now let's start. So remember just now I said that the first step in text processing is tokenization. So that is the most important step here. Step one, tokenization. So you can just call the functions, call word tokenize. You're going to tokenize this string into individual words. So you can just run this first. You will see that sometimes you have this problem. So you just scroll down, it's okay, you just scroll down. Look what is the suggestions given from the notebook one. So it says that I missed out one library here. Then you just copy this and I'll take download UNKT. So you just paste it here. Once again. Done. So you will see that this is the original is a sentence. So now I tokenize it. I make it into individual. Hi, Mr. Smith. So this individual here we call it as a token. But in NLP I will call it as a feature. Token or feature stuff. Okay, I will break the whole sentence into individual. Yeah, this is the board. No. How come?
cannot look.
Cannot load ah? You can.
Maybe this computer.
Hey, you can. Only you cannot. You download again. Yeah, you also cannot. Identity is not defined. You haven't downloaded the case, is it? Go up. Oh. Close it. Okay, you go up. You have to import this identity. treat this one. So you have to check. You have this actually window pop up. Then you have to download all the file. How you download all the file? You have to click the download. Then you wait download everything. So this is one way to download. So otherwise, you cannot run it. You have to stop. You have to run and then download everything, and then you wait. Okay. After download everything, then only you can run the second this line number 3 here. Okay. If very slow, then it's okay. You can try later. Let me explain everything first. So the business here is a bit slow. Okay. So you can see that from here I've break the whole sentence into individual token. Okay. So sometimes you will need to tokenize based on the sentence. For example, in this case, okay, hi Mr. Smith. So I will just bring it become a so-called one token. But it's very rare we use this technique. Normally we tokenize the word instead of a sentence. Okay. So after you tokenize it, you can perform a series of pre-processing, as I mentioned here. You can perform a series of pre-processing. So the pre-processing inside the notebook here is not limited to only what's going on the screen. You can check what else the pre-processing is suitable to your application. I will just show you some of the important pre-processing in NLP. First is the remove the punctuation. Okay, so how to remove the punctuation? Here is one of the techniques, only one of the techniques. I'm using regular expression. If you're not really happy with the regular expression, you can just go to the Google research, remove punctuation item. So then it will show you quite different ways to remove the punctuation from a string. So here is just one of the techniques. So after you remove it, you can see that all the comma here has been gone. So as I mentioned, comma, punctuation, exclamation mark, all are not very important in NLP. Okay, what is important is the word, is the frequency. It's the frequency. Unless maybe you are studying sentiment analysis. You want to study whether a person is angry or what. So then you can study, for example, you have a word, hello. Then you have an exclamation mark. Maybe in this case, the exclamation mark is very important, then you don't remove it. But in this case, I remove it because for me, the punctuation is not important. So it depends on the application. So after that, I convert it to the lowercase. So this is a must because we have to standardize all the words. So we don't want the machine treat Brandon, big B, and the small b are the different things. So we want to then treat the Brandon are same features. So we convert to the lowercase. We move to the numbers. So this one is also depend on the application. Some application maybe you making the values is very important. So in this case, value is not important. So I remove it. Stop word. As I mentioned, stop word is a list of words that is not significant. That is bring a value, minimal value here. And you can see actually this is the list, the English word that is not really significant. Okay, so whenever you have this kind of word in your sentence, because being before, it will be removed using this library. This library will detect and remove for you automatically. Okay? So after you remove the stop word, check and this code. So what does it mean? So this code here is actually consists of 3 processes. This code, okay, this code is having 3 processes. So count vectorizer here is one of the main functions that located in the sklearn. So sklearn is one of the famous library for machine learning. Whenever using machine learning, you want to do prediction, whatever, sklearn is one of the famous library. Okay, and under this sklearn, you have one important function called count vectorizer. So what is the count vectorizer here? Normally, we apply this count vectorizer together with the stop word function. So this is count under one package. So what does it mean by this sentence? So this count vectorizer stop words here is referred to first tokenization. Okay, first tokenization. Tokenization. After you tokenize the sentence, we will count the frequency. We will count the frequency. Okay. Okay, how many times the Brandon occur this, and this. And then the third time, I think before the count, we'll remove the stop word. Okay, remove the stop word, and then only we count the frequency. So this package is placed under this count materializer stop word English. Okay, what does it mean by this sentence? It's actually to tokenize it, remove the stop word, as well as to count the frequency. If you run this code, what will happen? Okay, you will see this very funny value here, 0.1, 0.6, 1. So what's the meaning? So machine is very sensitive to value. If you have this word here, the machine will not count the word based on this string. First thing what it will do here is it will convert this one of the word into maybe some code, 0001, one hot encoding, for example. You will convert this gift into some another one hot encoding, 0002, change 0003, maybe 0004. Then only we do the counting. That's why you will see that you will see some value here. So this is just some code represent each of the words. And then this is the frequency. This is for the machine to understand. Okay? So in order to let the human to understand, you have to use another function called get feature string. Get feature string means that we are going to convert this code back to the features. The feature, remember what is the features? The words. So we are going to convert this back to these features, back to the name. That's why from here, eventually you will see there's another table. Okay, you will see there's another table from the one hot encoding or the frequency, we convert back to the words that's actually understood by the human. Okay? Alright. Understand now? We'll just take it. Okay, so next we have a lemmatization. The next process, lemmatization or the stemming process. So you can see that we have two different processes to convert some interactive word back to the original word, stemming or lemmatization. So there are some difference between the stemming and the lemmatization. What is stemming and lemmatization? Okay, what is the purpose? So we talk about the lemmatization first. Lemmatization, as I mentioned, we convert this kind of word running back to the original word. Okay. So what is stemming? Stemming is just like you have a tree. You just prune the branch. You want to prune the branch. Okay. You have a word, for example, driving. Okay. Drive. Running. So if you use stemming, we just cut away or remove this interactive word, for example, ing. It will return you dring. So drive. So maybe we will remove es for you. So it will return you dring. Running, maybe return you. I'm not sure what is this. I'm not sure how much the output. You can try later. Probably it will return you RUNN. I'm not sure that. So this is the stemming. Meanwhile, this is lemmatization. Lemmatization is a technique where you convert to the original word. That is, the word back is actually original from the dictionary. It's from the dictionary. If you use stemming, the word may not from the dictionary. You might question, then why do we need to use stemming? But remember, if your application you just want to compare some document, for example, you have two documents here. You want the machines to identify whether these documents are the same. This is document 1. This is document 2. So I have a word called driving. So I have a word called drive. If I use stemming and remove it, I get dring. So this I will get dring also. Is it important I convert this back to the original word, which is from dictionary? It's not necessary, right? I just want to compare whether these two documents are the same or not. So for us, whether this drive or drib doesn't matter. As long as we just want to compare whether these two documents are the same. Then we can use stemming. Okay? So we use stemming just to compare the documents. When to use lemmatization, you use lemmatization where the context or the meaning is very important. Where you like to return something back to the user at the end. Google Translate. Okay? Maybe text summarization. right? You can't return DRIV back to the user. Then you have to use lemmatization technique to convert back to the original word and return to the user. Okay, but the lemmatization is going to take a lot of time. It's more complex, take more memory. So remember, whenever you want to decide which one to use, you have to check what is the application that you want to use first. Then you decide which technique to use. But the purpose of the planning and the lemmatization are the same. They want to convert this word back to the original word. Okay. So how to apply? It's very simple. You just call this function called Lancaster Stammer from this library and authenticated STM stemming. If you search from the Google, there's not only Lancaster Stammer, there are a lot of techniques available. So I want you to try, maybe back home later, you try different techniques on the stemming process. Same goes to the lemmatization. Here I'm going to use wordnet lemmatizer, but in fact there are a lot of different functions, different lemmatization techniques. Okay, let me finish another two, then I will let you to try again. Okay. So the next one is called part of speech tagging. So what is part of speech tagging? The purpose of part of speech tagging is to find out the relationship each of these words, between each of these words. What is the relationship between Jasmine and the leaf? So after you apply the tag of speech tagging, it will show you that Jane is actually a noun. Leaf is actually a verb. It will show you the syntactical structure of a sentence. Okay? So why do we need to study the syntactical structure of this sentence? If you look at this word properly, L-I-E. What is the meaning for this word L-I-E? What is the meaning of this word? Huh? Yeah. What is the meaning for L-I-E? Yeah.
Stay.
Real time?
Yeah, okay. You say real time. It could be a noun. Real time. Live, right? This is a live. Real time. Someone said it's a verb. Living. To stay. Okay? So you have two different meanings. Without analyzing the syntactical structures, the machine wouldn't know that this live here, do you refer to the first one or are you refer to the second one? So by having this syntactical structure analysis, the machine will know that you are referred to a word called live, staying. So when you type this sentence into the Google will analyze that you are looking for a person. Live is a verb in somewhere else. It's not going to return the information related to the first one about live band or about the live. No. So this is very important to analyze the syntactical structure of one sentence. Is that clear? One of the reasons why you study is to solve this kind of so-called semantic ambiguity. Okay. After we analyze the post tagging here. Give me some time. Okay, after analyze. Then the next step, normally what we will study is called NER, name entity recognition. Okay, so after you perform this NER, if you further analyze, just now we analyzed the syntactical structure, right? James Smith is a noun. Live is a verb in United Kingdom. United Kingdom is a noun. But if you perform the NER, you will further analyze that the James is actually a person. United States is a location. Okay, it's a location. So that is able to solve against some of the nouns that having different meaning. For example, apple. Apple, it could be a product. apple watch apple. Apple could be also the fruit, right? So if you just, without analysis here, we just put this sentence apple, some sentence that includes the apple, the Google may confuse, the Google search may confuse. Is this apple, are you referred to the fruit or are you referred to the product? So by having this detailed analysis, the Google search will understand that what you are looking for. Are you looking for a product? Are you looking for a fruit? So if you further analyze for each of these now, is it a person, is it a location, is it a date, is it a time, is it a product or whatever. So that is the purpose for NER analysis. Okay? And then the last one is the compound term extraction. So what is compound term extraction? So look at this word. This food is not bad. If we have this string, we perform tokenization. You will read the whole sentence into individual words, right? So after that, let's say now you want to study the sentiment analysis, whether this food is good or bad or not. So we will study this, bad. Bad is actually a negative word, right? Bad, something is negative. Not also something is negative. So by studying this whole sentence, tokenize it, the overall sentence here will give you something negative. But this is not true, right? Because not bad is actually referred to something good. So you have to define the define. Instead of tokenize it, you have to compound. You have to join this word before the analysis. You tell the machine that this not bad is actually one term, considered one token. It's cannot be separable. It's a one token, and this is actually something positive. So if you study the overall sentence, eventually it will return you positive. Okay, so this is the important why we need to perform a series of analysis. We need to compound the term first. NLP is simple, but to really analyze the string is not simple because you have to consider a lot of real situations. The pre-processing, the step here, I'll just cover it just so very simple. What if let's say you have an emoji, you have some abbreviation, you have some bahasa rojak, you have some sarcasm, then how to analyze it? So I'm not going to cover here, I'll just cover the fundamental one. How to solve the sarcasm emoji, that one will be another lesson, another level, okay? So, okay, so we have another 10 minutes. I want you to try from the beginning. So let's try start from the beginning how to install. I see a lot of students that start here. Okay. I want you to download through the prompt, through the Anaconda prompt here, not through the Python notebook. From here you type PIP, install NLTK. Okay, you download the package through here, then you will see that our requirement already satisfied. So after this stage, you can close it, okay, and run these 2 lines of code. I think this one, just import NLTK. Okay, just this line of code, import NLTK. Run this code and continue. You will see a problem, you will see the errors. You try to go down and check what is the errors that provided or given by this notebook. Sometimes you will give a suggestion, you will miss out this library, you just copy this library and put inside your notebook and run again. For example, just now, before I insert this code, you show me the error and you will give me a suggestion that I missed out this line of code. So I will just copy that line of code and put it here and we run again. Same goes to the rest. How vectorizer has no get feature field. You copy this, put in the Google. This not here. Put in the Google.
So just now, that's what, that's positive
This one, yeah. It's one title. Title is a term, compound term extract what? Extract the term, down. Yeah, it's a compound term extract. So it's called compound term.
So what is I may add an out get usually out.
If you try, we to run lah. You didn't change anything lah.
The function is different, right?
Huh?
The function is different.
Sometimes due to different version they change the function name one. So maybe for me the version is okay. Maybe for you the version is already updated or outdated. You need to use different function, but they perform the same thing, just different name.
They use very hard already.
This is the limitation for Python. When you use Python, you will feel very annoying one. You use this name out, you can run here. When you use a laptop, you can run already. Then you have to check the version, the compatibility, everything. But all the solution is available in the Google lah. That's the good thing lah.
当你 run 是才要 import， 像你一开始要写的 predict 没有这个嘛，所以你要自己加一个空格，然后去 import 它，然后再放这个样子。你这里它会有，它会讲好像好错啊。error 没事，好放松。啊？什么 Brandon？
他想你啊，他不想你过啊，他想你啊。
要咩？
要嘛？
谁要？谁要？谁要？他8点很开心。
那有到。
可是我们每天上到6点。
所以今晚又在 BRG 了。
干嘛？
要命！
我内卷。我内卷。我这个现在没有成绩不好，还要 FYP 搞一下。怎么办？会让他做我毕业吗？
我宁愿考虑，我宁愿还是在考虑，可以带个口，还可以轮
就是让你的全部变强。
So can your last chapter be to movie?
Same problem. So if you have this problem, okay, search Google.
有点私下不好看。
Sometimes different versions of this partially, but they perform the same thing. Oh, 哎呀，2个小时多啊！哎呀，我也
哦，接着我们那边有没有到
So, too bad, because due to the time constraint, there are actually quite a lot of things, quite interesting one I cannot cover lah.
老师你要做 online class extra hour
I got no extra money.
没有卖，不用紧，我们 extra knowledge 吗
Oh,
You get extra GPA 啊。
extra today.
Yeah 5.0 yeah.
But I think it's okay lah. Next week I will cover the applications. I'm going to show you how to build a simple application to predict a gender based on the name, as well as how to predict the sentiment through the review. Next week, 2 applications. Okay, so this one I will, if let's say next week, after the explanation we still got time, then I will come back to here lah. So otherwise you can just go through first the solve. So TextBlock is actually just another library. So just now we covered NLTK. So NLTK is one of the famous libraries. So we have another library called TextBlock. So TextBlock can perform almost similar things like, for example, tokenization. Tokenization here. Yeah. So this is the tokenization. Same as the NLTK. NLTK, what we use what tokenize. TextBlock we use TextBlock. TextBlock here. Then we will show you tokenize. So we give you the same output, just we use different library, different functions. So it's up to you. So this one you can go through. So besides the tokenization, TextBlock can perform the spelling checker. Yeah. So Android GRAAT. So it will check. It will find out, oh, this is something wrong with it. GRAAT. So it will so-called repair the words back to the correct words here. So yeah. So this one, let's see that in our time. Then we probably can come back here. Especially this part, the term frequency inverse optimal frequency. Okay. So far, any questions? So this one another big topic, So if got time, then I do extra class. If no, then 保重。Why?
没有time就保重，自己保重。
Yeah.